Hey guys, this video is going to go over how to sort of format our position time graph data. So what we did previously, if you're not sure how I got this graph, I'm going to go ahead and delete this. This is my sample data from a video in which I recorded at what time object had reached these specific positions as it was rolling down a ramp. Here's my experimental data. And so what I'm going to do is if I want to plot this data, I'm going to highlight what I want. I'm going to hit insert. I'm going to choose a scatter plot. Now, do not choose the one where the lines are connected. That's not a thing. Don't do it. Choose this one. Okay. And so what I have here is I have my position time graph. And so first thing I'm going to do is I'm going to make sure that I give this a position versus time. I'm going to give it a title. Now, this number means nothing unless I label my axes. And so down here, my x-axis is time in seconds. My vertical axis is position in meters. And I do want to add a trend line to this. Now, something I want you to sort of notice, you may not be able to tell very well, so let me make this bigger, is that this line actually is not, it's not a straight line. It's not a perfectly linear line. This line is actually slightly curving. And so the reason why I want to point that out is because, now this is for my data. Your data might be completely different. But the reason I point that out is because that is going to change what type of trend line you add to this, okay? So if I add a trend line here, and again, all I did is I clicked the plus button, I went to trend line, and I checked the trend line. I'm going to click this little arrow right here. Now here's the thing. If I look at a linear trend line, if I look at my linear trend line, I want to make sure I set my intercept to 0. I'm going to delete that first one. But it doesn't really fit my data beautifully. Okay, and so we can actually get a much better trend line by changing it to polynomial, and look at how much better it fits. That is because for my particular object, remember, if you have a position time graph that is curved, that means that your object is accelerating. And so what I'm going to suggest to you to determine whether or not your object is accelerating or if it has a relatively constant speed, toggle back and forth between a linear trend line and a polynomial trend line, and that is going to help. Whichever one fits a little bit better is that's the one that's gonna be best for you. So because I know that my object was accelerating, I'm gonna choose this curved one. And so here's my position time graph. Now, part of what you're supposed to do for this activity is you also needed to generate a velocity versus time graph. So what I'm actually gonna do, I'm gonna take this guy, I'm gonna just drag him right down here because we don't need him right now. But if you look at my data table, I don't have velocity data yet. So what we can do is we can generate our own velocity data. So first thing I'm going to do is I'm going to highlight these because I don't want to have to do more work than I really need. Okay. Oops, I don't want to do that. I'm just going to type this here. I'm going to do average time, and I'm going to put in average velocity in meters per second. Now make sure that we put the units in, we want to make sure we put our units in our headers, because if we put units in these boxes right here, Excel's going to think that it's a word and not a number. So what I'm going to do is I'm just going to I'm going to transfer the times that I have previously. Oh, I inverted that. Now, obviously, your data set might be a little bit smaller, but I have lots of data points because I wanted to have a really good looking graph. Okay, so here's all of my times. Now, in order to get my velocity, you need to remember that velocity is position divided by displacement divided by time. So if we remember that, oh look, this is the displacement that we measured, over this period of time, well, what I can do is I can just tell Excel to calculate that for me. So what I'm going to do is I'm going to put in a formula. I'm going to do equals this displacement divided by this time. And I'm going to hit enter. Now, this one's not going to work just because you can't divide by 0. So what I'm actually going to do is I'm going to put 0 in that one. But it's going to calculate here. So I'm going to do it again. I'm going to hit equals this displacement of 0.1 meters divided by this average time, hit enter, and it gives me a velocity. And if you want, you could keep doing that, equals this displacement of 0.2 meters divided by this time and hit enter. But Microsoft Excel is mwah, chef's kiss beautiful, because you see this magic little green button right here in the corner? You can drag this down and it just repeats it for you. Pretty nifty. So what I'm going to do, I'm going to make these numbers pretty because, you know, significant figures. So I'm going to do it like this. And now what I'm going to do is I'm going to generate another scatter plot the exact same way that I did the position time graph. I'm going to highlight my data table. I'm going to highlight the points that I want. Now remember, this works best if you make sure that your first column is your independent variable, or your X, what you want to be on the X-axis. So in general, that's always going to be time. And if the second column is your dependent variable, or what you really want to go on the Y-axis. So I'm going to highlight that, insert. I'm going to come back and I'm going to put in another scatter plot. There we go. Boom. So there is that data. Now, that being said, I'm going to go ahead. Actually, I'm going to delete that point because it's going to mess up my data. It's going to mess up my data. So what we have here, no, actually, I'm going to keep it. So what I'm going to do is I'm going to go ahead and label this velocity versus time. I'm going to do the same thing I did before, where I'm going to make sure that I label my axes. Now remember, this one is time in seconds. Now this one is going to be velocity in meters per second. So I labeled those. Now what I want to do is I do want to add a trend line here. Okay, we definitely need to remember that we want to add a trend line. So I'm going to go to my little chart elements. I'm going to check trend line. But what I'm going to do is I'm actually going to go to this options. I'm going to hit more options because I want to see my options here. Now I'm going to tell you, do not pick polynomial this time. Choose linear. Okay, you definitely want to choose a linear scenario. Okay, and so this is going to be our average velocity time graph. Make sure that you display the equation. And if we're looking at this equation, remember that the slope of a position time graph is acceleration. So I hope this helps you guys out. That being said, let me know if you need any help, and good luck.